Julien Verlaguet, so Verlaguet for those who can pronounce it. And I work in the HipHop team at Facebook, and I'm going to talk about an interesting project that we've been developing in OCaml. So first, a couple of words about HipHop. HipHop is the team that tries to make PHP faster, basically. It's the compiler team. I can imagine that there are a bunch of PHP fans in this room. Maybe not, but I'll try to make the best of it. So first, a couple of words about PHP and what it's good at. And yes, it's good at certain things. So this is the list of things that you would hear about if you had a conversation with somebody who works at a startup or somebody who does PHP in their spare time. This is the list of things that they're going to mention. They're going to say, well, it's everywhere. If you have Apache, you have PHP. They're going to talk about the libraries, and they're going to say it's easy to learn, etc., etc. So except for the scale part, Facebook doesn't really care about any of that. If you look at all these points, point by point, well, the fact that it's easy to install, we have enough people who can deal with that. The fact that there are a lot of libraries, we have enough resources to build our own. But there's one thing that we do care about, and it's that. It's a very fast feedback loop. And so actually, when I first joined Facebook, I did most of my work on compilers, and it had one very well-defined input and one very well-defined output. And I realized that the kind of workflow that you need when you're trying to build an experience, whether it's on the web or on a mobile phone, is very different. The kind of development workflow is that the problem is there is no good way to write unit tests for an experience. So the only way to get that right is to iterate very quickly. So what you do is you start, so here I took a random PHP programmer, you might have recognized him, who had an idea in 2004 and started building a website and then iterated quickly to make that website feel right. And as of today, that's still the way people work at Facebook. They start with a prototype and carry on iterating quickly. Now, the problem is that PHP at our scale comes with many challenges. So the first one is performance. I'm talking about runtime performance here. We have many, many machines, and at this kind of scale, even 1% regression in CPU is completely unacceptable, because more CPU time means more machine, and that has financial implications. So performance is really critical. The thing is, PHP wasn't designed to be heavily optimized. And so it's hard to optimize in the sense that there are many dynamic features in the language. And it's not impossible, but the runtime will have to rediscover many of the invariants at runtime. So that's for the performance side, but there's another side that is difficult as well, and that's the development itself. So I let you imagine hundreds, thousands of engineers working on a PHP code base. Well, it makes things a bit difficult, because let's say you're trying to do something as simple as renaming a method. And just finding all the spots that you have to refactor is difficult in a dynamic language. In a static language, the type checker would tell you, go and check all these things and update them. In a dynamic language, well, you have to find them for yourself. So unit tests are going to help, but they're not the perfect solution. Then there are certain classes of bugs that are only caught at runtime and that we would like to get rid of statically. And finally, the tooling is primitive. So here I mean auto-completion, I mean all sorts of tools that make your life easier while you are developing. So now I'm going to talk about the first architecture of HipHop. And that was, the original project was two backends. There was a PHP source code, and on the left was an interpreter that was interpreting the PHP, and that was used in sandboxes by developers. And that was to keep this very quick feedback loop. And then on the other hand, there was the compiler that was targeting C++, and the C++ was itself compiled to binary code. The problem with that model, so there are two problems. The first one is that the interpreter actually got pretty slow. We have so much PHP code that running an interpreter was starting to take a significant amount of time. The other problem is that the compiler, the C++ compiler, was wasn't reflecting anymore. It was hard to get a mental model of what was going to happen at runtime in our dev boxes. The two models were getting so different that it was hard for a developer to predict what kind of performances they would have at runtime. So what happened recently in the last 3 years and was shipped last year is that these two backends have been merged into one. And now we now have a JIT compiler that is used both in sandbox and in production. So it's not yet a perfect split. There's still optimization passes that are only run at, for production code, but the two models are much more similar. So now the interesting thing that happened after that, and that's what I'm going to talk about today, is that we now have a new language that targets HHVM, and it's called Hack for HipHop. And so one thing that I would like to stress out is that HHVM is still a PHP platform. And in fact, we try to become a drop-in replacement for the existing runtime. And the fact that it supports Hack, that now it has two languages that are supported, doesn't change the fact that it is still a PHP runtime that fully supports PHP. So now I'm going to start talking about Hack, the real topic. So what is Hack? So it's a statically typed language that targets HHVM. It is fully compatible with PHP, and what it means is that there is no overhead between the two worlds. What it means is that you don't have to write FFIs, you don't have to write stub code. A Hack object can be used from PHP world and vice versa. The both are perfectly compatible. Another important part is that it evolved from PHP. And the reason why this is important is that we wanted our developers to keep a clear mental model and for them not to have surprises at runtime. So what it means is that if you know PHP, you are not going to be surprised by the behavior that Hack has at runtime. And finally, and that's mostly due to our scale, the model has been such designed for incremental adoption. It was completely unrealistic at our scale to switch from a dynamically typed language to a statically typed language all at once. So we needed a path to get there. And the way we built that was through gradual typing. And I'll show you in a second what it looks like. So now I'm going to show you very quickly what this actually looks like in practice. I hope everybody can see this. So the magic command is HH, which means Hack for HipHop. That basically tells you about the state of your directory and if there are no errors in it. So now I'll write a very simple function. And what's interesting about the error message is that it comes in multiple parts. The first part, the first line of the error message is telling you what the nature of the problem is. And then the rest are indications to the programmer on how to fix the problem. And in fact, if you look at this error, what's happening here is very simple. What we do is during the inference, the inference algorithm always keeps a witness of why it thinks that something has a certain type. So now, the way to use it is first call the type checker, then go to the error line, understand what the nature of the problem is, and then either fix this and put a string there, or fix that. In that case, it would mean to remove it if we wanted to return void. So voilà, that was for the little demo. Now, and it actually works. So now, a couple of words about the type system itself. So what we wanted to minimize the amount of work that needed to be done to adopt Hack, And so what must be annotated are only class members, function parameters, and return type. And all of the rest is inferred. Now, I said earlier that the annotating process was an incremental process, and I'll show more in a second what it looks like in practice. I'd like to say a couple of words about the types themselves. So in fact, the type system starts to be pretty rich, and I'm going to start with nullables because null is a real problem in PHP. It's a real problem because it converts to anything. You have null, it turns into false, that turns into the string false or the string 0 or God knows what. And so for our developers, it is critical for them to get that right. And so having a type that can guarantee that this value is not null at runtime was crucial. And so some of you may know may refer to this as the maybe type or the option type, depending which world you come from. But remember that there's no pattern matching, and that we had a huge code base that had been designed without pattern matching in mind. So we had to work around that. There's another, well, all the others I think are going to be familiar to most of you, except maybe for the syntax. I mean, the syntax is more C inspired, and when you look at PHP code, it makes sense. The two interesting types these are relatively new things. There's the type aliasing, which allows you as well to create abstract types, and extensible records. So I hope this gives an overview of the kind of things that you can do. But I think the best way to actually show you this type system is to show it to you in action. And what I will try to do is show you what it takes to go from PHP to Hack and how this process actually works. So I had a little test PHP file. If you look at this code, it's really not doing much. It's a class, that's a mailbox. You can send data to the class and to the mailbox and fetch data back out of the mailbox. So two very simple methods, send and fetch. And your first original step is going to write HH at the top. So HH at the top means this file now lives in Hack for HipHop, and I want it to be type checked by the type checker. So when you save the file, you can now call the type checker, and this file has been included. Now, of course, since I said that we needed to add type annotations in order to make the type checking happy, right now there's not much that has been checked. There's not much that happened. And in fact, there's a way for you to see what is type checked. It's to use an option called color that will show you which part of your code is checked and which one it isn't. So if it shows up in red, it means that it's dynamic code and you should be careful. Now, let's try to take this file and actually type check it. So we're going to add annotations. So I'm going to start with a string to make things simple. So here you get an interesting message. It tells you that it is not properly initialized. And I said earlier that null was really evil in PHP, so we statically track what has been initialized and what hasn't been. So I'm going to add a simple string here to just make the type system happy. Then the send function, well, it looks like it takes a string and it's returning void, and the fetch functions returns a string. And finally, my little test function here looks like it's returning a string too. So now I want to know as well when I'm done. So here I annotated everything, and as a programmer, what I want to know is, okay, am I done now? Is everything type checked? Well, you have a way of adding this by adding strict mode. And strict mode will complain if anything left in this file hasn't been statically type checked. So now it's going to complain because of dummy call here. So I added this call on purpose, of course. And you now have two options. Either you go in the file where dummy call is defined and you convert it to Hack itself, or in that case, since it's a dummy call, you just remove it and we're done. Now, as I said earlier, the the null type is everywhere, and people tend to initialize their fields with a null value. In that case, I cheated a bit because I put an empty string there. So I want to show you a bit what the process looks like when it's an empty string, when we initialize with null. So here it's going to complain because it says that it's a string and it was expecting a nullable type. It's going to complain here too because of this guy, so let's fix it. And here, that's the interesting case here, is that, well, we could carry on like that forever and put question mark string everywhere, but eventually we really want to use it as a string, and that's how you do it. You check if it's not null, and if it's not null, you can use it as a string. So basically the type checker here is picking up the fact that you checked that the value was not null before you can use it. So what's interesting as well is that, well, since we have more generic type, what we can do now is replace our strings here with more generic values, and it still works because this mailbox actually works with any type. But what is interesting is this witness system I showed you earlier gets pretty handy when you use generic types, because it will show you where the error comes from. So here I'm going to make a mistake on purpose and send an integer. And if I look at the error message, it's telling me invalid return type because I was expecting a string here, and it's pointing you to where it deduced that it was a mailbox of int. And that can be quite useful.
Can you send 0 on the string? What happens?
Can I send what?
You can first send 0 on the string.
You can first send 0?
Put another sender that has a 0.
That's not going to work.
Because you have to have either string or either. No, send 0 first on this string.
Okay, sure.
Whatever you say.
Right.
So T must be either.
Not exactly, because you could return a mixed, and I guess this would work. It's because so that's going to work because now you picked up the fact that it can be either one or the other. But in that case, if you're saying string, then sure, he's going to complain about your int here. Now, if you have mixed, then fine. Go and put whatever you want in your mailbox. All right. That's for... So now I would like to say a couple of words about performance. And as I said at the beginning, what was very important for us is a very fast incremental loop. And if you introduce a type system over millions of lines of code that is too slow, nobody's going to use it, and it's not going to be a very successful project. So here I wrote a very simple function that is a function bar that doesn't do much. It takes an integer and returns void. And I created a bunch of classes, and all what these classes do is call the function bar. So I'm going to take 27 as an example, is that it calls the function bar with an integer. And I want to show you what happens if you modify the code. So here that works. So I'm going to introduce a mistake here with a bool. And you can see that we got instantaneous results with over 7,000 lines of error messages through thousands of files. Now, I can change it back and actually measure how long that took. So that was pretty fast on 1,000 files. Now, last thing that I'd like to show you is that since we had all this nice type checking, and one of the aim was to get tooling, we developed an IDE, and this IDE actually works in a browser. And that's one of the things that where OCaml came handy, because we could take the type checker and compile it down to JS, and so embed the type checker in the IDE. And so now what you have is stuff like autocomplete, where everything works client-side. So what's really happening under the hood here is that we go and fetch the data that we need from the server, and once it all lives client-side, we can run the autocomplete on the client side. So that's pretty exciting.
I think I'm going to cry.
So now what I would like to talk about shortly is a bit about the internals and how this works under the hood, because it was actually pretty challenging. So we had to work at scale, and we had a set of constraints that were very well defined. So first we knew exactly that we wanted to build an IDE, and we knew that our code base was going to be huge. We're talking about millions and millions of lines of code. And so of course, what we could have done is build a normal compiler that takes an input and an output. The problem with that is that we knew that the latency wouldn't be good enough. So what we decided to do instead was to make a server, a daemon, that maintains the state of the world at all times. So we have this daemon that is running, and whenever you change the file on disk, through iNotify by listening to the kernel events, we go and update the state of the world behind your back. Now, the constraints are pretty challenging too. So we needed very low latency, especially for things like autocomplete, as you have seen, but there are others. A second very, very big challenge was revision control. So we have users who use Git, and it's a very large repo where 10,000 commits rebase is a very common thing. And they have several branches, they want to switch branches, and when they switch branches, they want to be able to work straight away. So we needed a server that was able to keep up with that kind of load. Of course, well, there are the classic constraints, which is the RAM. You can't use too much RAM. The initialization time was kind of important too, and stable. Stable, I think, is by far the most important one, because developers want to be able to rely on their tooling. It's pretty important to them. So what we did is that we wrote it in OCaml, and that's the interesting part. So in fact, it's a mix of OCaml and C, but the vast majority of the code is written in OCaml. And it was very good because for symbolic computation, well, it comes with pattern matching, it comes with many nice things. It has very good performance, and as you've seen earlier, the fact that you can easily target JavaScript was a very important feature for us. Finally, it interoperates well with C, and I'll show in the next slide a bit of the architecture and how this mattered. There was one challenge, and I think you'll hear that a lot for those who program in OCaml, which is that there is no native support for multi-core in the OCaml runtime. But we managed to work around that pretty effectively, and we still have we use all the cores of the machine through this architecture. So the architecture consists in having a master. The master knows where everything lives and knows where the data is and what needs to be done. Then it distributes work to the different workers. And the workers, when they get jobs to be done, but they don't respond to the master with their data. Because if we were doing that, the bottleneck would become the master. So what we do instead is these workers, they talk to shared memory, and that's where the data goes. So of course in that little diagram it all looks nice and simple, but the C layer here is horribly complicated. These are lock-free, this is lock-free C code that, well, we couldn't even use locks because of performances. This is pretty hairy, and it was pretty handy to have a team that was working on a JIT who are experts on the hardware and can get these things right and help us get these things right. But fortunately, the API was relatively simple, and we managed to keep most of our code in OCaml. So a couple of things about OCaml at scale. If I had to advise you on how to get this right, I would say start simple with pipes, sockets, and the kernel actually works pretty well. And then go for the more complicated stuff after a while. A couple of things to keep the latency low. What we did is the workers that you've seen in the slide before, we make sure that their heap is always very small. So we try to keep the amount of data visible to the worker as small as possible, and that's to keep the latency, to keep a good latency. So OCaml makes you think hard about the parts of your code that are going to share objects concurrently, and I tend to think that that's actually a good thing. You should think about these things very carefully. And voila, that's it. Any questions?
We have time for one question, and after you come up and set up, I'll deal with that.
So how much of this is available for us outside of Facebook?
None of it. It's the first time. We're going to open source it soon, but in fact, it's the first time we talk about it publicly.